In this video, we will look at the cooling capacity, electrical consumption, working pressures, and the capillary tube of the 1/5 HP compressor that uses R134a refrigerant gas. 1. The cooling capacity of a compressor mainly depends on the compressor's efficiency and the temperature required at the evaporator. 2. The cooling capacity of a real 1/5 HP compressor varies substantially between models. It can be around 500 BTU per hour, 126 kilocalories per hour, when operating at a temperature of -20 degrees Celsius -4 degrees Fahrenheit. 3. On the other hand, if the temperature is -10 degrees Celsius 14 degrees Fahrenheit, or slightly lower, the cooling capacity is close to 1000 BTU per hour, 252 kilocalories per hour. 4. Now, regarding the regular electrical consumption of the 1/5 HP compressor, it essentially depends on the supply voltage. For a compressor powered at 120 V, the current consumption will be approximately 1.6 amperes. While for one powered at 220 V, the consumption will be about 0.85 amperes. 5. The working pressures of the compressor operating with R134a can be checked in our simulator. First, we are going to set a condensation temperature of 45 degrees Celsius 113 degrees Fahrenheit, a superheat of 5 degrees Celsius, a variation of 9 degrees Fahrenheit at the evaporator outlet, and a subcooling of 5 degrees Celsius, a variation of 9 degrees Fahrenheit at the condenser outlet. Remember that the access link to our simulator is available in the video description. 6. If we select an evaporation temperature of -10 degrees Celsius 14 degrees Fahrenheit and consider an altitude of 500 meters above sea level, we will obtain the following pressure values. 7. Now, if we select an evaporation temperature of -20 degrees Celsius -4 degrees Fahrenheit at the same altitude of 500 meters, the pressure values will be as follows. 8. Next, we will use our simulator to find the appropriate capillary tube size. Let's start with the capillary tube for an evaporation temperature of -10 degrees Celsius 14 degrees Fahrenheit, typical of refrigerators, remembering that in this case, the compressor's cooling capacity is about 1000 BTU per hour, 252 kilocalories per hour. On screen, we can see the approximate capillary tube measurements provided by our simulator. 9. Now, we do the same for an evaporation temperature of -20 degrees Celsius -4 degrees Fahrenheit, where the cooling capacity is around 500 BTU per hour, 126 kilocalories per hour. On screen, we can see the approximate capillary tube measurements provided by our simulator. Remember that the access link to our simulator is available in the video description.